Okay, let's look at a slightly harder question that we need to apply quadratic factoring to, and it might not be immediately evident. So we have this one here where we have x plus 1 squared plus 6 times x plus 1 plus 9. So the first thing that really jumps out at me is the fact that this binomial and this binomial is the same. So if I make that observation, that means I can actually apply quadratic factoring quite quickly. However, let's say I didn't make that observation. Let's just see if there's another way to do this. One way to do this is to initially actually expand and then simplify. So x plus 1 times x plus 1 plus 6 times x plus 1 plus 9, which is going to give me x squared plus 2x plus 1 plus 6x plus 6 plus 9, which is going to give me x squared plus 8x, 6, 7, 8, 6, 7, 7 plus 9 is plus 16. So I need two numbers that multiply to give me 16, but add to give me negative 8. And I see that this is actually a case where it's a perfect square, so I have x minus 4 squared. Because notice, 16 squared is negative 4 times negative 4. Okay. So that's one way to do it. The other way to do it is to just do this all in one step. So this is what I like to think of as a better way. What I can do is I can take this x plus 1 and just imagine that that x plus 1 is like any other x that would be there. So what I'm going to do is I'm going to factor, I'm going to try, let's do this. Let x plus 1 equal z. So wherever I see an x plus 1, I put a z. So z squared plus 6z plus 9. So then what I do is I say two numbers that multiply to give me 9, but add to give me 6. And of course that's z plus 3 times z plus 3. So in this case, because I said let x plus 1 be z, after I factored this, I have to put back in wherever there's a z, x plus 1, oh, pardon me, x plus 1 plus 3, x plus 1 plus 3, which gives me x plus 4, x plus 4, and I have the same answer. This little substitution helps illustrate what we're doing, but often what people will do is we'll write to this x plus 1 plus 3, x plus 1 plus 3, which is x plus 4 times x plus 4. And we're done. I hope this helped.